Assalamu alaikum everyone, and our today's topic is electric field and its intensity, or electric field and electric field intensity, right? So we're gonna first define what exactly is electric field. The region around a charge in which an electric test charge would experience an electric force is called electric field, right? So we're gonna just take a region around a charge. Okay, we're going to take a point around a certain charge and place a certain test charge on that point, and then we are going to just calculate the intensity of that electric field over there. All right, so electric field is the area around the charge where the force of that charge could be felt, right? So any area around this charge where this small charge would experience any force of attraction or repulsion is called the electric field. The field around an electric charge is called the electric field in simple words. Now, how are we going to know whether where is this field stronger or where is this field weaker, or like stuff like that? What is the intensity of this field? Okay, so the strength of the field as experienced by a 1 coulomb charge at any point is called electric field, right? The strength of the field as experienced by a charge at any point is called electric field intensity, right? So if this charge is placed near this charge, this is a test charge, and conventionally we take a positive, we usually take a positive test charge, okay, just conventionally. So in most of the books you'll always find a test charge to be positive in nature, okay. The test charge should be very small as compared to this one, so that it won't just disturb the overall distribution of field lines. I'm going to tell you what exactly are these field lines, or in simple words, it should be small so that it won't disturb the attractive or repulsive force of this charge, okay. Because if it's large, if it's a large charge or a massive charge, so it is gonna just affect the intensity of the electric field of this charge, okay. That's why we're gonna just use a very small charge, so it could be neglected as compared to the larger one. Now it is denoted by E. It's a vector quantity, of course. We have arrowhead over E. So electric field intensity is denoted by E mathematically if Fe is the force experienced by a test charge. Q naught, okay, Fe is the force experienced by a test charge. Q naught, then electric field intensity E is given by the formula. So electric field is the force experienced by this unit test charge. In simple words, this is very simple and important formula for the electrostatics. Electric field E is simply the force on this charge, right? If the force on this charge is greater, then the electric field intensity would be greater. The electric field will be more intense. And if the force experienced by this positive charge will be weaker, then the electric field intensity will be weaker, okay, or the electric field shall be much less intense in that case. The unit of E is neutron per coulomb and is a vector quantity, right? So this just shows that how intense the electric field is at any given point. If we want to just test the electric field intensity at this point, we are gonna just place this test charge to this point and then we are going to use this formula. Okay, F, we're going to find F, which is equal to, I've already told you about the Coulomb's law, F equals to KQ1 Q2 by R square, right? F divided by the charge carried by this this mass. Okay, it obviously has a mass, so this charge which is placed over here. Now, how are we going to just show that there is a field? Of course, we cannot just see an electric field. Okay, so how are we going to show which area has a stronger field and which area has a weaker field? So obviously in this line you cannot tell that at which part of this line the electric field is more intense or is less intense. So to show the intensity of electric field at different points around the charge, we use electric field lines. As you can see here, in these green arrows are just for the demonstration. All right, so we are not going to use this in our numericals or our actual problems. Okay, so just look at this diagram. This one is for positive charge and this one is for negative charge. These lines, okay, these lines, these black lines, not the green ones, these black lines are the electric field lines or lines of electric field or electric field line. They're basically the same thing. Now, as you can see, in the case of positive charge, these lines are directed outwards, and in the case of negative charge, these lines are directed inward. It is just a convention, right? It just shows that when these two charges are brought closer, the field lines will be directed from positive to negative. I'm just going to show you right here. Okay, if we are going to place these two charges very close to one another, then this thing would happen, right? Like this or like this. Okay, this kind of you can say like this. Okay, this kind of distribution of field lines will occur if we place these two charges close to one another. Okay, this is the case with the opposite charges. The field lines will be directed from positive charge to the negative charge. Okay, so in every case, whenever you draw field lines, don't ever forget to draw these arrows, which should be directed from positive to negative. It doesn't mean that the field is actually traveling. It just shows the force of attraction. All right, if I wouldn't place a negative charge over here, if there was a positive charge, then these field lines would be directed away from these charges, and there will be a field lines like, I'm just gonna use another color pen, okay, like this one. If, let's suppose this is a positive charge, right? These two are positive charges, then what would happen? These kind of curves would be made. Okay, all right. Okay, so this is the case with the same charges. If this is a positive charge, then these lines will have arrows like this, the outward arrows, and the arrows coming in opposite direction will never meet. Remember that. Okay, in the case of opposite charges, the arrows will meet because they were all directed in a certain direction. But in this case, in case of two positive charges or two negative charges, of course I'm taking the case of positive charge, these arrows are not going in the same direction. I cannot draw a line like this because these arrow will just won't follow a same path. these arrows were going in this direction and these arrows were going in this direction in case of positive. Okay, so in the case of positive charge, they're never gonna meet one another. Okay, this shows the case of repulsion. But in the case of opposite charges, okay, same charges, in the case of same charges, they're not gonna meet one another. And in case of opposite charges, they are gonna meet because they will be directed in one direction. Okay, so hopefully it would work for you. I'm gonna just share with you another video in a three-dimensional area of this line. Okay, a three-dimensional demonstration of how field lines are actually distributed, what exactly these field lines look like. All right, I'm gonna just share a video so that you can better understand using this demonstration. Right. All right, this is all for today. Thank you so much, everyone.